we have this question to walk through. The decomposition of benzene diazoxide chloride is given by the equation. So have this equation here, this is benzene diazoxide chloride, so it's giving us phenyl chloride or benzene chloride plus nitrogen gas is given off. Now the rate constant of this reaction is 0.105 per second at 20 degrees centigrade. Starting with a concentration of 0.066 molar per mole per dm cube or moles per liter of benzene diazoxide chloride, calculate its concentration after 6.6 seconds. So how do we solve this problem? Let us look at the data given to us from the question here. The rate constant K was given to be 0.105 per second, and then the reaction started with an initial concentration CaO of 0.066 molar, that is mole per dm cube or per liters, and then we have to calculate the concentration after 6 seconds. So final concentration we don't know. Then time during which they want us to calculate this concentration is 6.6 seconds. So what do we do here? The first thing we need to do is to find out the order in which the decomposition of benzene diazoxide chloride followed. And how can we actually determine the order of the reaction here? Because it was not given in the question, as in it wasn't stated. This is why knowing the unit of the rate constant is extremely important. Now, from the rate constant unit given to us is per second. Is that okay? So this is a first order reaction, because for first order reaction the unit for K is per seconds. So alright, this is first order reaction. First order reaction. Or of course I've said because of the unit of K. So that being the case, we're now going to recall the formula for calculating the final concentration when a reaction is modeled in line with first order. So that's going to be ln Ca1 equal to ln CaO minus Kt. Now we know all the things in this equation apart from Ca1, which is what we are calculating. So we can substitute ln Ca1 is now equal to ln the initial concentration CaO is 0.066 moles per dm cube. Then that's going to be minus the rate constant given to us is 0.105 per second. We're going to multiply it by the time 6.6. So the rest is all about calculator now. Is that okay? So we're going to have ln CaO, alright, ln Ca1 rather, which will now be equal to ln 0.066. So let's find out. Ln 0.066. It's giving me minus 2.7181 approximately. Then minus we have 0.105. We're multiplying it by 6.6. So that's it's giving me 0.693. Okay, so ln Ca1, that's ln of the final concentration, we're going to find out minus, this is minus 2.7181, so minus 0.693. So from here it's giving me minus 3.4111. To get the final concentration Ca1, we are going to take the exponential of both sides of the equation. Because when we take exponential, we remove this lane. That will be left with the final concentration we're calculating. So this is going to be exponential negative 3.4111. So let's do this and see. Okay, exponential of negative 3.411. So from here, it's giving us the final concentration to be, okay, so we have an exponential of negative. Let's find out exponential of negative 3.411. So from here, the value is 0.033, which you can still write as 3.3. In standard form, move the point 2 times to the right. That's 3.1 to 3.3 times 10 raised to the power minus 2 molar. molar. That's moles per dm cube or moles per liter. So this is the value of the final concentration for this problem. We have this second question on the board here. The half-life of the radioactive isotope phosphorus 32 is 14.2 days. How many days does it take for a sample of phosphorus 32 to lose 93.75% of its radioactivity? So I want to solve this problem and see what we are going to arrive at. Now, from the question, we're given half-life. The half-life, T-half, of phosphorus 32 is 14.2 days. That's what was given to us. And now we are asked to find how many days. So we don't know T, all right? We don't know T. What we know is half-life. We don't know the time it will take for something to happen, but we know the time it will take for phosphorus 32 to lose half of its concentration, all right? Now, from the question again, we were given that, okay, how many days does it take for a sample of phosphorus 32 to lose? So it's going to lose 93.75%. This question is given to us in percentage. It means that the initial concentration of phosphorus 32 is 100%. Once a problem is given to you in percentage, the initial concentration is taken as total percentage. Is that okay? And total percentage is going to be CaO. So total percentage is 100%. So the final concentration is going to be 100 minus 93.75, since it's going to lose this quantity. So the final concentration that will be left, what will be left will be 100 minus that value. So let's find out. 100 minus 93.75. Okay, so that's equal to 6.25. So this is 6.25%. That is what will be left after losing 93.75%. So this is what we are going to do, okay? We know that to calculate any given time during which it loses a certain value, leaving a final concentration, the formula for first order is ln Ca1 minus ln CaO. That is ln of final concentration minus ln of initial concentration equal to Kt. Is that okay? That's equal to minus Kt. That's the formula. So for this problem, to calculate this particular time, we are going to recall that ln Ca1 minus ln CaO is equal to minus Kt. Is that okay? Now this is the time we are asked to find. That's the time we are asked to find. We don't know the time. But if you look at the parameters given to us in the question, we know Ca1 already. We know CaO in terms of percentage, 106.25% respectively. We don't know this T. We don't know this K. And we're asked to calculate that T. So you can see that now, right? For us to be able to get this T, during which it will lose 93.75%, we must know the rate constant first. Now this problem is going to be modeled in line with first order rate of reaction. The reason is it is a radioactive problem. Radioactivity is modeled according to first order reaction for the decay process. Is that okay? Don't forget that. So since it is a first order, we want to get K first. Alright, get K first. Get K first. And that is why we're given the half-life. So we can get K. So I'm going to say that but T half for half-life for first order is 0.693 divided by K. I've told you why we are using first order to model this problem. It's a radioactive problem. So K is equal to 0.693 divided by half-life. And half-life is 14 days. 14.2 days given in the question. So let us now find the value of K. Is that okay? So that's going to be 0.693 divided by 14.2. And from here, the value of K is 0.0488. You know, for first order, the unit of K is per second. Our problem is solved. Now we've known K, we can substitute here and then get the value of what? T. It implies that, coming here, you know this ln Ca1 minus ln CaO, using logarithm law, it can be written as like this. Subtraction law of logarithm equal to minus Kt becomes ln CA1 is 6.25 divided by 100, then equal to minus 0.0488, which is our K, times the time we are looking for. So all we need to do, the time will now be ln 6.25 over 100. We're going to divide all this by minus 0.0488. And then the time we are looking for will just appear. So are you ready? Let us find out what that's going to be. I will punch that straight ahead. So ln 6.25, we're going to divide it by 100. Okay, it's giving me minus 2.7725 and other things. So I will now divide the whole thing by minus 0.04488. Good, that is 56.8. So T is equal to 56.8 days. So for our problem, this question is going to take phosphorus 32 56.8 days to lose 93.75% of its initial concentration.